Okay, good day, everybody. Welcome back to KodeCamp DevOps Bootcamp. Um, Today we are going to be talking about AWS and AWS services. We will specifically speak about the compute services that we have in AWS, and we are going to look at how the compute services are and how we can use them while working with the cloud in AWS. Okay. So AWS compute services are computing capacity that's is provided for us by the AWS cloud. It helps us to run our applications and manage workloads and data processing data processes on the cloud. Basically, AWS cloud platform, AWS Amazon Web Services created compute services that can be accessed on demand. That can be accessed on demand for people that need them. I hope you can all hear me. So AWS has data centers that are distributed across various regions and various availability zones within those regions, right? So that just means data centers in various countries or various areas in many countries where they have computers and servers and machines set up that people can access on demand to run their workloads and deploy their applications. So these compute services are computers, or we can see them as processing machines that can process our workload and help us to have access to computing power. So the services that AWS offers with cloud compute are flexibility, which is it provides a wide range of services, a wide range of compute services where we can choose from various services for our various use cases, right? It also provides scalability. It gives us the ability to increase the capacity of what we are working with to provide for more workload. In a situation where you start out with a particular number of a particular amount of traffic to your workload, you can improve your processing by getting a better a more advanced compute type, or you can increase the number of compute services that you have purchased from AWS, right? And then there's cost efficiency, which gives you a pay-as-you-go pricing model or an on-demand pricing model where you pay for what you use, or you pay for the amount of time that you use these compute services that are being rented to you by AWS, right? So in the past, when you are building an application, you would need to also set up your own machines, your own servers. But companies like AWS and cloud companies have taken that burden off developers and off software engineering teams, where they host, they provide the data centers and you just rent out the resources that you need, including compute resources or storage resources or any other service that you need, as the case may be, right? So one of the first compute services, one of the more important compute services that AWS offers to its customers is Elastic Cloud Compute, which is EC2. Elastic Cloud Compute just provides scalable and optimized virtual servers for cloud computing, and they are usually called instances, right? So AWS provides for you and provides for its customers virtual machines, virtual servers that they can use and they can access to run their workload, to run their various processes. There are many types. AWS offers various types of Elastic Cloud Compute Services, depending on the use case of the user. right? So it enables users and customers of AWS like you and I to choose the best and the optimal um, type of cloud compute at the most efficient cost, taking into consideration things like the networking capabilities, the compute capabilities, the storage capabilities, the memory capabilities, right? And some of the key features, some of the things that AWS provides for us through Elastic Cloud Compute includes auto scaling, which we talked about previously, where we can automatically um, increase or decrease the capacity or the type of server that we are using, right? Um, this allows for better management of the cost you're spending on these resources. Looking at some of the types of EC2 compute instances that we have. Um, we have five types of instances provided by AWS based on the kind of workload that you want to run. So we have the general purpose instances, which have a balance. We have general purpose instances. We have the compute optimized instances, which we are going to look at. We have the memory optimized instances. We have storage optimized instances, and we also have the accelerated compute instances, right? So that if you're running a type of workload or a type of application that needs more storage, for instance, maybe you want to run a database on a server, you will need more storage capacity than if you just want to run a simple web server, right? So the kind of um, server that you need for a database will be different from the type of server you need for a web server. And it would not be balanced if everybody has to pay the same thing when a certain type of application needs more storage or more memory capacity than another. And so this just helps us to also optimize the kind of costs that we are spending, our cloud spend, our cloud cost, helps us to optimize it better. So general purpose instances provide a balance between the compute capacity, the memory capacity, and the network resource capacity of the server. And it makes it suitable for a wide range of applications, right? You can use this for many types of applications where you might not necessarily need more memory capacity or more advanced compute capacity for your server. So you have the T series and the M series of instances. We are going to look at what that is moving forward. So you have the T series, which provide bustable performance instances, which means that your performance can increase as you use it more. And then you have the balanced compute memory and network resources. This is suitable for small databases, development environments, and web servers. Your compute optimized instances now are designed for more intensive compute applications that will need we need higher performance processors. We need much faster, much advanced processors for for the kind of workload that you're running, right? So these are the C series of instances, and they offer high CPU to memory ratio, right? And this makes them the best or the optimal choice for high performance web servers and batch processing workload, for instance, where you want to perform you want higher throughput, you want more work to be done at a more optimized speed on accuracy, right? So you use the compute optimized instances which give you higher CPU and higher processing performance. For your memory optimized instances, these type of instances are designed for memory intensive applications to deliver fast performance. So when you have things like where the memory is more for applications where the memory of the application is more important than maybe the processing, right? You use a more advanced memory instance, which is your memory optimized instances for things like the maybe you want to have big data processing, right? You want to run things like ETL jobs, right? That is extract, transform, and load, ETL, which is just a concept in data engineering, right? Things when you're working with a large amount of data, you know that you need a lot of memory, right? As opposed to maybe just being balanced and everything. So you should opt. AWS, Amazon provides memory optimized instances for that kind of workload, right? So in this category, you have the R series, which gives you high memory to CPU ratio. We also have the X series, which gives you memory optimized capabilities for high performance databases. Right? Some of the use cases for these memory optimized instances include in-memory databases, things like Redis, things like Memcache, where you want to have cache data, right? So you want to hold data in memory within your database. So you use a memory optimized instance for big data processing, real-time analytics, those kind of workloads. You should opt for memory optimized instances, right? They are designed for that kind of workload. You also have your storage optimized instances. Here, storage is the priority, right? So you have your storage optimized instances that help you to handle workloads where storage is more it's more of a concern than memory or CPU or things like that. Here you have the I series and the D series. Some of the use cases like NoSQL databases where you have MongoDB or Cassandra or such applications. You have data warehouses and distributed file systems, right? So speaking to the pricing of EC2, right? We mentioned earlier that Amazon provides for its customers on-demand pricing model where you pay for what you use, maybe per hour, your build based on what you're using, based on the capacity you're using, right? So for this, we see that the pricing of EC2 instances is mainly dependent on the type of instance that you're using and how long that you use that instance. So in light of that, there are three types of pricing for EC2. There's the on-demand pricing, there's the reserved instance, there are reserved instance, reserved pricing, and spots instances. So on-demand instances are the pay-as-you-go model, right? Where you pay for the time that you use for the model. If you have an instance running, the amount of time you spend running that instance, you are billed for that time. And when you stop the instance, right, you stop being billed for that instance, for that EC2 instance that you have running. For the reserved instances, you can decide that you want to rent out an instance for maybe 1 year or 3 years, and you can get some incentives for that, right? Maybe you can get a 20% discount or a 30% discount because you've rented out the server for a long time and you've giving that amount of commitments on using that instance, right? So reserved instance is like you're going to give the commitments to AWS by buying the instance and renting it out for 1 year or more, or more than 1 year based on the requirements and based on the needs of your organization, right? And AWS gives you a discount on that price. Spot instances are like bidding for how this pricing model works is like you bid for instances, and whoever gives the best price for that gets the instances, and you're able to save data on that instance because AWS doesn't give you a commitment on that instance. The instance can be retrieved. That compute capacity can be retrieved from you um if there is need for that instance from AWS, right? So you use this, maybe you want to run a development environment and you don't need you're not looking to have a large amount of reliability, then you can go for spot instances. Okay, looking at other compute services that AWS offers to us, because there are a wide range of compute services that AWS offers. So some other AWS compute services include AWS ECS, which stands for Elastic Compute Service. Elastic Container Service, rather. So ECS provides you an Amazon proprietary solution for managing your containers, right? So your Docker containers, we're going to talk about containerization soon. The Docker containers can run on AWS ECS, which provides you management services for your containers, right? It has a seamless integrations with other AWS services and helps you to orchestrate your many containers, right? The service is ideal for running microservice applications, batch processing, and machine learning workloads. AWS provides you security, reliability, performance, and helps you to manage the control plane, right, for your ECS. So you are left with just managing maybe the worker nodes. It provides some form of container. It's like a container orchestration tool, right? When you're working with microservice applications, you will need an orchestrator for the various containers and the many containers that you're working with. AWS provides this solution for that. It's fully compatible with Kubernetes. It's automatic scaling and self-healing, and integrates with AWS services seamlessly. You also have AWS Lambda, which provides serverless computing. In AWS Lambda, you don't have to worry about the compute that you're using, right? You just want serverless computing, right? That's like when you talk about serverless computing in AWS, that's when we look at things like AWS Lambda, where you have your workloads run as functions, and AWS runs those functions on servers, but it abstracts the management of the servers from you, and you have your only area of concern will be the workloads and the functions that you're working with. So AWS Lambda is a serverless compute service that automatically runs code in response to events without the need to provision or manage servers, right? So it abstracts the provisioning and management of servers from you, and you just focus on running your code. Users pay only for the compute time consumed, and also for your executions. So you pay for your compute time, which gives you better cost management for short-lived and stateless functions, right? So if you just want a function to just run and just for a short period of time, maybe something like a repeated short process, right? Maybe you want a part of your system that checks the time for you and performs an action at a particular time of the day. You don't need that to be running on a server and you're spending money on the server. Meanwhile, you need this events to run only at a particular time of the day. So you can have that run with Lambda so that you can pay only for the execution, which is when that code is run and the time it takes to run, right? So AWS services make it ideal for real-time file processing, data validation, and some other backend operations. Some of the features include automatically running code in response to events that may come up, no server management, and pay only for your compute time. Okay. Next, we have the Elastic Kubernetes service, which is AWS's managed Kubernetes service for running Kubernetes environments and Kubernetes orchestration. So Kubernetes is a container orchestration tool. It's AWS. It works with a control plane which has some components that are used to manage what we know as the worker plane, right? Which are two different. So the control plane is made up of some components that help you to manage the other planes, the other clusters. That's where your containerized application. So AWS helps you to manage that control plane, and then you now focus on managing the worker plane. So you pay AWS for the services it does in managing a control plane for you in the form of a cluster. So when you create a cluster, you pay for that and you pay for the amount of time that you have your cluster running. Okay. So EKS is fully compatible with Kubernetes and enables users to migrate standard Kubernetes applications without having to refactor their code. So you can deploy on your Kubernetes environments with EKS. EKS provides a Kubernetes environment for you so that you don't have to manage both your control plane and your management plane for you, depending on the size of your team and the type of organization that you're running. EKS also works with EC2, right? So the EKS serves as a means to manage if you want to manage some EC2 instances as part of your cluster. AWS provides the EKS environment for you to manage the control plane, and then your worker plane can be set up using EC2. Okay, right? So EKS automates key tasks such as patching, node provisioning, and updates, making it easy to run Kubernetes applications at scale, whether for container orchestration, deployments, or CI/CD flows, right? So some of the control plane operations such as patching, node provisioning, updates, scheduling, and things like that is managed fully by the EKS by Amazon, and you just focus on deploying and running your applications using Kubernetes. So some of the features of this type of compute provided by AWS include the fully managed, it's fully compatible with Kubernetes, and it is updated regularly to the latest version of Kubernetes, so that you're always up to date. It's also performs automatic scaling and self-healing, and integrates seamlessly with other AWS services. Next, we have Fargate, which provides a serverless compute engine for containers and eliminates the need to provision and manage servers. Right? You can use Fargate with both ECS and EKS, and it provides a more flexible and scalable way to run your containerized applications without even having to manage servers. Fargate allows users to specify and pay for resources per application, which is a beneficial feature for microservice applications, batch jobs, machine learning workloads, and it gives optimal resource utilization and cost management. Some of the features from Fargate include the elimination of the need to manage and provision servers yourself. It works seamlessly with ECS and EKS and provides you an on-demand pay-as-you-go strategy for running your nodes. Next, we have AWS Lightsail. Lightsail offers you an environment, a cloud platform for running simple web applications and websites. So Lightsail has pre-configured applications, pre-configured setups that you can use to run common applications, things like WordPress, maybe Node.js. They have that pre-configured for you with things like networking setup, storage setup, DNS setup, certificates, and a lot of pre-configured things set up for you. So you just need to come there and do minimal configurations and have your simple infrastructure set up and run for you using Lightsail. Finally, we have AWS Batch, which is a fully managed service for running batch computing workloads of any scale. AWS here with batch service allows you to dynamically provision an optimal quantity depending on your type of compute resources and the volume of workloads that you want to perform with your batch process or your batch job. So you submit your batch job and to batch process, but AWS batch, and it processes from you. So batch can help you to plan, schedule, and execute batch workloads across a full range of AWS compute services and features. This is usually used for data processing workloads, big data analytics, and a lot of processing workloads that require a lot of data and can be run simultaneously. Okay. All right. So to conclude, we've looked at the various compute services that AWS offers. We've looked at EC2, we've looked at ECS, containerized EKS, Fargate, Lambda, AWS Batch, and a lot of other services. And we've also talked about the pricing strategy that AWS uses for all of these services. So depending on the needs and requirements of various types of users and various types of teams, AWS provides compute capacities for its users. Okay. So that's it on AWS Compute Services. Are there any questions on that before we go into looking at the practical, looking at some of these services practically? Okay, go ahead, Michael.
Yeah, good evening. Can you guys hear me clearly?
Good evening, Michael.
So I was actually trying to go through, I was going through the whole this thing that you were saying from the start, and I just wanted to be clear on something. So there are services or instances that you can actually use inside another instances, correct? Or is there like there's only like a set of instances that I can accept multiple instances in them, and then there's some that cannot? Because I want to know how we're going to categorize them in case of memorization.
Instances that you can run other instances inside.
Yeah. Hello?
Could you be clearer? You're asking if you can run an EC2 inside
Like,
another EC2, for instance.
no, like not the same instance. Like, for instance, you mentioned where maybe like lightweight now. Can you also run that inside another instance? Or is it like those ones that can you hear me? AWS lightweight.
Okay, Lightsail.
Sorry, right. So I kind of the word this are not clear, but I just want to know if there are like categories of instance that can accept other instances in them, or is it that one way or the other you can actually get to interchange them or interuse them in any way? I don't know. I'm trying to piece up the question, but I just want to know how I'm going to categorize them based on what kind of distinct features that they have, differences from each other.
Okay, so instances are like servers, right, that are provided for you. So you can request for a particular server of a particular type, right? Depending depending on the kind of workload you want to run. Is it something that is compute intensive or memory intensive or storage intensive? And you can pick from the various types of instances and run a specific type of instance. You can't run one EC2 inside another EC2. I don't think that's possible. But you can pick from many ranges of instances, right? And you can pick various number of instances to run your workload, right? So yeah. With Lightsail abstracts the management of servers from you to some extent, which we are going to see later. It helps you to just deploy applications for you and gives you a pre-configured infrastructure for that, right? Okay. So go ahead, Adediji.
Good evening, sir.
Good evening.
Yes, sir. Please, is it possible to tell AWS the kind of instance you want? That is, if all these listed instances, this type of servers does not fit into all you want to do, probably you want to do something that combines like two different things. Is there a way you can tell AWS, these are the things I want, then you pay for that particular service provided?
Okay, so most of the time, depending on your workload, your needs and your requirements will fit into most of the things that they are providing, right? Most of the categories of instances that they are providing. But if you want a server dedicated to yourself, right? You want to have a server just for yourself. You don't want anybody, because most of these servers, you don't own them. They're just rented out to you for a particular amount of time to perform your needs. If you want one server to yourself, you can pay for what is known as a dedicated server from AWS. That is on a more enterprise level. It is more cost intensive to do that. But most of the time, your requirements, your needs will fall under the provided categories.
All right, thank you, sir.
Okay, thank you. One more question. Okay, so I think we can go into the practical look of some of these things, right? Okay, so I'll just share my screen quickly. Hello, can you still hear me? Hello?
Yeah, we can see you, sir.
Okay, thank you. So we will begin from EC2. Now, okay, so looking at our EC2 dashboard, right, we see this provides us shows us the number of instances we have running, shows us our elastic IP, number of load balancers we have running, instances, we have auto-scaling group, dedicated hosts. So this dedicated host is what Adedeji was asking about. If you want a server to yourself, right, you can use a dedicated host specifically to yourself, set that up and work with that. But we are going to look at instances today. So to set up a server for yourself, you can come to launch instances, and here it allows you to name your server and pick from a wide range of operating systems provided for you, right? So you can have you can run various operating systems here. From Microsoft to Debian to Ubuntu to Mac OS to Red Hat Linux. And these come as Amazon machine images, AMIs, right? Packaged as templates. You can see here that an AMI is a template that contains the software configurations, which include the operating system, application servers, and applications required to launch a server or launch an instance for you. You can also create your own AMIs, your own machine images. Say you want to have an Ubuntu machine that has MySQL running on it, that has some specific applications that you want and require for your team or your application, and you want that as an image that anybody can launch anytime. You can create that within your organization. So coming back to this, You can see that there are various images that you can run with various operating systems, right? Okay. So coming now to instance types, right, that we spoke about. So we see select an instance type that meets your computing, memory, networking, and storage needs, and your price based on that. So let's see the instances. So these are the different compute instances that you can work with within AWS. And this just shows a view of most of them. So you have T instances, which are your bustable general purpose instances, right? You see here that this has one virtual CPU. That is like your processor, one vCPU, and 1 GB memory. It's a pretty, it's small server, right? Network performance low to moderate. And you have A instance types, which run ARM architecture. Now look at this C type of instances, which are the compute optimized instances that we have, right? You see here that the vCPUs are like two vCPUs. You have this one that has 16 CPUs, 16 cores here. You have 32. So depending on the type of compute you need, and this is the memory, and you also have the network performance here. So this one has like 72 VC cores that you're working with. If we go to look for memory optimized instances now, which like we saw here, memory optimized, we are looking at some R series and X series. So you can see some of the R series here with 768 gigabytes memory. So depending on the kind of workload you want to run, you have various instance types here for you, and you can select that. So we've looked at some of the instance types. So you can pick your instance type based on some of these things. We can also come to reserved instances. Assuming I want to purchase an instance for up to a year, I can specify the term to be 1 to 12 months or 12 months to 6 months. And the payment option, I can pay partial upfront or all of it upfront and buy this instance or rent it out completely, depending on my kind of workloads. Can also come to sports requests, right? Now, if I come to something like, so So you can bid for instances with sports instances, and the highest bidder gets that particular instance. This graph is showing you the the prices that have been bid for this kind of instance, this C3 large instance, I can do C. Say I want to do C3 million, for instance. So you can see here that this is the range it has been on for the past week, which is between 0.01 per VIP CPU to 0.19. And with this, you can save up to 58%. But it is not very reliable, given that you can lose the instance if a higher bidder comes for it. So that's some of the things that we have for EC2. We go take a look at Lambda, the Lambda service, for instance. Now, so AWS Lambda lets you run your code, run your workloads without having to think about servers, right? You pay only for the compute time that you consume. And when your code is not being run, when your code is not running, you're not paying for anything. So when your code is executed, and the amount of time it takes to complete its execution, that's what you pay for using AWS Lambda. So you can simply come and create a function, right? And when that function is executed, you pay for that using AWS Lambda. So that is the concept behind serverless computing. Okay. AWS Cloud, Elastic Cloud Container Services, ACS, provides a fully managed container orchestration service for you using ECS. So this is a highly scalable and fast container management service that makes it easy to run, stop, and manage containers in your cluster. So saying you have a smaller team or a team that doesn't need to use Kubernetes, right, to manage its clusters, that just wants to get its clusters up and running and have AWS do most of the management of the clusters, you can work with ECS, which makes it easy to deploy and manage Dockerized containers and run services and batch processes. So you can easily create a cluster here and use your target definitions to run your services with ECS. Okay. EKS as well. This provides you in EKS, AWS manages the control plane for you, and you would manage the nodes by yourself, right? So you can connect to your cluster in this. You create a cluster which basically is a set of nodes for you, and you can then run your containers using Kubernetes, which helps you to orchestrate your containers. And lastly, we have Lightsail. Look at Lightsail. Okay, so with light sail, you can set up the kind of infrastructure that you want. It's pre-configured for you with app and windows. You can set up WordPress here. You can set up a Node.js application, right? You can set up something like Django if you want to run that. And this doesn't just provide you with the operating system like in EC2. It also gives you the ability to have some pre-configured applications installed and running on the sites. It also offers that with different prices depending on the kind of capacity that you want to run for this. Also, this is also giving a easy setup process and more straightforward, depending on your need and your workload. So Lightsail just makes it easy for you to get up and running with your applications pre-configured for you. So yes, are there more questions on this? Okay, Michael.
Okay, just to get clarity on something. There are instances that lets you manually configure, do a lot of configurations, while there are also instances that does that, but then not, it doesn't let you do anything. AWS still does some configurations for you or handles some parts. Is that what am I on point with something there?
Are you talking about Lightsail?
No, not just Lightsail, like all of the instances that are available. So there are some instances that is it that there are some instances that AWS handles some configurations while you do the rest, or AWS does most of the configurations and all, and then there are other ones that you have to actually manually do all of those configurations for yourself. Hello? Hope you get the question.
I'm trying to understand the question.
Okay, the question is this. Let me repeat myself.
Yes.
They are saying that are you trying to say that there are instances that's where AWS helps you with some configurations or with some settings, like for instance, maybe to give you a server or the kind of operating system that you're going to use to launch your applications. While there are some that you actually require the user, it requires the user to actually manually configure them.
Okay. So when you're working with EC2, what you're talking about is the compute service, right? Not just the instance. When you say instance, I understand that to mean like an EC2 server itself. But if you're talking about
EC2.
compute service, you do some of the configuration yourself, right? Most of the configuration is done by you. If you do some configuration and see that this is a stable state for your application to run, you can save that configuration as an image, right? And run that and deploy that as a server, right? So if I set up a server and I install Apache Apache web server on it, I install Nginx on it, I install a Postgres database on it, and I bring that to a stable state for my application, and I want to be able to have that image saved. Image meaning that this configuration now is saved for me to be able to use later. I can save that as an Amazon machine image, right? Now, Amazon has some pre-configured setups that they've done for you in certain images, right? So if we know that there are a lot of people that want to have Apache on their system, they want to have Postgres on their server, they want to have Nginx on their server as well. There is a certain type of customers that want these three things, right? We can create an image for them and tell them, okay, this image is for web application developers, for instance, right? This image. So if you're a web application developer, you want these three things set up, you can run this image. Yes, so there's some images like that. You can run that, use those images, those templates, those images to set up your server. Now, looking at some of them, for instance, this is AWS Marketplace now. So you see here that there are some companies that have also created images of things that people can use to easily set up a server, right? So if you know these companies, Palo also, you see that this image, right? Panorama Network Service Management enables you to control your distributed network and firewall. So this server can be used to easily set up and configure firewall. It has some things from Cisco, from Fortinet. Go to category DevOps. Right. So these are images that you can use to set up your server, depending on what you want to run. Just for instance. Okay. So was it Michael? Michael, could you come back up?
Yeah, I'm here.
Yeah. So do you want to ask another question, a follow-up question? Or do you understand what I explained?
Yes, now I realize that I now understand that there's a marketplace, just the same way Docker has base and Vagrant.
Exactly.
And that's a lot. No
So I
problem.
can
There'll
have
be subsequent questions later.
images here. So these are just images, machine images that you can use to run your server. But if you just want a blank slate operating system, you can also get that running as well, which in a sense is also an image. Do you understand that?
Yeah.
All
Perfect.
right, thank you. Chika, please go ahead.
Hello, good evening, sir. Sir,
Hello, good evening.
please, my question is, I want to understand. Oh, can you help me clear? Can you help me define the difference between EC2 instance and light sail?
Okay. So with EC2, you want to set up a server, just a server, which is just a computer. But Light Sail provides you a platform, right, that you can use to set up an application infrastructure, right? So if you want, I can decide to set up a server that will run AWS, for instance, right? In that server, I also want a database, right? So maybe I can make it to have MySQL in it. I can also want maybe a proxy service on it, proxy process on it. So I put or load balancing. So I put in I put in Nginx, for instance, and I set that up by myself on my server on EC2. Now, with Lightsail, AWS provides that for you already set up and configured, right? So it takes it abstracts you away from a lot of provisioning operations and a lot of server management operations that you might need to do if you set that up by yourself, right? So depending on the type of team that you have, for instance, if you, Chika, now you have a client that says, I just want to set up WordPress. Maybe you might not want to have to manage the server by yourself. You want to have AWS do all of that, right? You just want to configure some things, maybe configure the WordPress site itself, right? You just want to design the site for him. So you're a web designer, you just want to design the site for this person. You don't want to bother about setting up servers, managing the servers, provisioning the servers, updating whatever you need to update, and setting up the infrastructure by yourself. You just want AWS to handle that, and then you design the application and give to this person, right? You can use Lightsail for that. So Lightsail will help abstract a lot of things, covers you from a lot of things, like a lot of management and operations activities that you will normally need to do. So that's just the idea behind Lightsail. Get it up and
Okay, thank you.
you're welcome.
Thank you. So you mean to say that everything I can do with EC2 instances, I can do it with Lysol.
Everything you
Just
can
that Lysol is serverless. It doesn't require me to put so much effort. Why in EC2 I'll have to put so much effort and do everything from
It's not to look at
the
it, but it's just like um operating activities, right? So there are some teams that need more control. There are some things you need to do that you need more control on the server, right? You can't use Lightsail for that. If you want to be able to set up specific kind of infrastructure designs, right, by yourself, proprietary kind of things, you might not be able to use Lightsail for that, because Lightsail is just like out of the box, take it as we've done it for you kind of thing, right? So you just specify maybe the number of instances, the region you want to run it in, and it might seem simple now, but it just depends on your requirements, basically.
Okay, thank you.
All right, thank you. Adedeji, you had a question, put your hand down. Did I answer it as I was speaking?
Yes, sir.
Okay, what was the question?
I wanted to ask when she said Lightsail, how flexible it is. Then another thing I wanted to ask is, does that make Lightsail more expensive than EC2 instances?
What do you think? Well, what do you think about that?
I think it should be
From a
more
business
expensive.
point of view,
I think it should be more expensive.
yeah,
Mm.
I think that's correct. So, but expensive now will depend on your use case, right? What you're trying to do. You can use EC2 and maybe you're provisioning a lot of servers, right? And you might not need that amount of servers. So maybe you're spending more than you should. Or maybe you're setting up EC2s and you're paying, from a business point of view now, you're paying an infrastructure team to manage servers for you for a product that you can just, have Lightsail do for you. So it depends on what your goals are as a team, right? But
All right.
when it comes down to it, running an EC2 server and setting up things by yourself might be cheaper, but that doesn't automatically make it the best option for you.
All right, sir.
Also
Thank you
doesn't
very
mean
much.
that's the best for you either. All right, thank you, Aditi.
Thank
Okay, so let me see if there are some questions in the comment section. Oh, good. Okay. Can you host a web application on Lightsail and have it available for everyone? Yes, yes. Having a web application available for everyone is a question of exposing it to the internet through your networking, right? So if you provision your Lightsail, application, if you set that up, you also have to set up your networking as well, right? Create a static IP and create, say, maybe some domain names so that that can be exposed to the internet. Yes. Okay, so I think this could be it for the class. Thank you so much, everybody, for joining. I look forward to seeing you in the next one. Goodbye.
Was my